So this is the second assignment for the second quiz in the third trimester of Algebra 2. So graphing logarithms, again, you're going to want a graphing calculator where you can graph things and look at them. You're also going to want some knowledge of the change of base formula so you don't have to mess with log base. So note how I entered that log of x over log of 2. So it's base 10, of course, when you don't see the base. So it's log base 10 of whatever's in the parentheses divided by log base 10 of whatever the base. So that's just kind of a number that's in the denominator. And that's something we did in the last unit. I made a big deal of that. There was a separate page of notes for that, but that's how you're going to want to enter every single one of these when you look at it. So find the x-intercept. This is where you let y be 0. And now you have to solve this logarithm for x. So this is where each thing goes into the power position with the base of 2. Okay, so this is just x on this side, and then anything to the 0 power is 1. So there's a lot of x-intercepts that are 1 on logarithms for that matter, just so you know that. Find the y-intercept. So this is where you let y be, x be 0. Sorry about that. And then you try to solve this. Well, if and this had to deal with extraneous roots, if it's ever 0 or a negative inside these parentheses, there is not, it won't work. Okay, so sometimes it's not the case. You know, it's some other number and it will work, but whenever that's the case, it will not work. And you need to know that most of the time on most logarithms, there's not a y-intercept. State the domain. So the domain is always related to the vertical asymptote. In exponentials, we had the range related to horizontal asymptotes. So x equals 0. Then we just need to, and the range, for that matter, on all of these is all reals all the time. Then we just need to take a look at the graph to see, okay, what side of the horizontal or the vertical asymptote, excuse me, are we on? Here's the vertical asymptote. We're on the right side of it. So this is x is greater than 0. So it'll always be x is greater than the vertical asymptote value or less than it. And those will always be the same. And for the most part, logarithms are that simple. 2, 1, just get a couple of points here. We're staying to the right of the vertical asymptote here, and then going up and up and up. So again, I'll be looking that you're getting this piece right here and staying on one side of the vertical asymptote. Okay, so we're going to have log of x divided by log of 0.5 using the change of base formula. Pretty simple. So the x-intercept, you're going to let y be 0. Again, this is equal to 0. So when you do all of this work, you're going to get 1 again. So anytime that left side, when you get the logarithm bare, you got to have the logarithm bare. And you do when you put 0 in. The time that it equals 0, you're going to get an answer of 1. Here, the y-intercept will not exist because when you put x equals 0 in, that's not allowed. You have to do it to get the y-intercept, but you can't compute it with logarithms. Okay, so state the range. We'll drop down there. That's always all reals. Just like in exponentials, the domain is all reals. Everything flips around. So the vertical asymptote, you are solving what's ever inside those parentheses equal to 0. I don't think I said that in the previous one, but that's how you get that. And then you just need to look and see. This needs to be 0.5. You need to look and see where the graph is relative to it. So it looks like greater than 0. So this again is always greater than this value or less than this value. And then from there, we want to just get some points on the graph. So 2, -1, 4, -2. Just get a couple of points that will give you the idea. So we're getting really close to the y-axis. It does continue down and down forever this way as this continues up and up. The idea is that you just want to get really close to the vertical asymptote in your work. Okay, problem 3. So we want to do log of -x divided by log of 3. When you go into, I just want to put a negative here. Again, you might have to use a graphing calculator site to do this. So here's what it looks like. So it's looking like we are left of the vertical asymptote there. All right, so X-intercept, there you let y be 0, and we solve for x. Okay, in doing so, we get the same thing. There's a 0 on the left, and so I'll do that work again so you can see it. Anytime that happens, all right, you're going to get 1 for the x-intercept, because each of these, so we're going to do 3 to the 0, and then we're going to do 3 to the log base 3 of -x. So this is going to be 1 equals -x. Oh, whoops, I was wrong. Good thing I'm showing my work. -1 is going to be it. Because of the -x, you have to solve for that x. So it involves dividing by -1. So 1 or -1 is going to be, that's why it's good to actually look at a picture of this when you do it. So find the y-intercept. This is where you let x be 0, and you can't have log base 3 of 0, so there's not 1. The range is all reals. The vertical asymptote is x equals 0, so whatever in the parentheses you take equal to 0, and you just get x equals 0, and then the domain is less than this because it's sitting on the left side of the vertical asymptote. So you just have to think, is my graph to the left or right, or bottom or top if it's an exponential? Here's sitting to the left of it, so that's less than 0. And then just go get a few points. You see where it doesn't exist there, so -1, 0, -3, 1, so on and so forth here. So we're coming through like this, and then just get really close with it. Okay, 4, find the x-intercept. Same idea here. So you have this same work going on, and you're going to get -1. Same idea. We need to just change our base here to 0.75, and then take a look here. But I believe it will be -1. Yes. So anytime that left side, we'll do the work again so you can see it. So this is going to get the base of 0.75 on each side. Okay, so this is going to be 1. Anything to the 0 power is 1. This is going to be -x. Kind of some awkward work there, but that's the work that you do to solve for a logarithm. You use an exponential. Okay, so -1. And then this will be all reals. This will be x equals 0. Again, you're solving what's in the parentheses equal to 0. We're going to get some on the next page where you'll have to. So less than 0 is the domain. And the y-intercept will not exist, again, because we're putting x equals 0 in, and it will not work in logarithms. So note that. That's the case. So opposite, when you do intercepts on any graph, it's the opposite one equal to 0. So let's get maybe one more point here. No, there's nothing good. So -4, -4.8, something like that. You just want to make sure you get it real close to the vertical asymptote in this case. Okay, a couple problems where you have to work a little bit to get the x and y intercepts because they'll both exist. So we've got log of x plus 3 divided by log of 2. There's the change of base formula again, plus 2. Let's just take a quick look. There it is. Now it doesn't, this is a vertical asymptote through -3. So we'll put that first. How did I get that? Take the inside here equal to 0 and solve it, and then you get x equals -3. And you see the graph sitting to the right of -3. Okay, so we know now that we have both a y and an x-intercept, which we need to figure out, and that's the real work on this. So x-intercept, this is where you let y be 0, and then we have to solve for x. So we have -2. And now we're going to do a base of 2 on both sides. So remember, in solving logarithms, the base of the logarithm determines this. And so this side is x plus 3. And this stays 2 to the -2. So subtract 3. That's really weird, but that's what x is, 2 to the -2 minus 3. And that's probably something that's really close to the asymptote. So -2.75 is the x-intercept. Y-intercept, let x be 0 and solve for y. This time it will work because when we let x be 0, we get 3 up here. So you just need to compute this. Log base 2 of 3 plus 2. This time I'll actually use my log base key, which is no problem. You can also do that. And that's about 3.6 on the y-intercept. So a little work solving for the x and y-intercept. We'll take a quick look here. So -2.75 and then 3.6. And then remember, we're getting really close to -3. And so I don't really care much about the rest of the points. You can just kind of do a whatever there. I care about when you get really close to that vertical asymptote that you're staying on one side of that. And remember that these values here are the same always. All right, problem 6. Okay, find the x-intercept. So this is where you let y be 0. And then we solve for x. So we're going to add 1 over here. 0.5 times x plus 2. And so we're going to do 0.5 to the 1. It's 0.5 to the log base 5 of x plus 2, which this is x plus 2 equals 0.5. So 0.5 minus 2 equals x. So that's going to be -1.5 for the x-intercept. And let's get a quick little look here at this. So this will be x plus 2, and this will be 0.5, and then -1. Okay, so there it is, and it's looking like -2 is the vertical asymptote. and that we're sitting to the right of that, remember those are the same, and the domain is either greater or less than that. This is all reals. And then the y-intercept is let x be 0 and solve for y. So log of 0.5 of 2 minus 1. So we got a little, use the change of base key again, which is okay to do. Or you can use the, I'm sorry, I meant the log base key, or you can use the change of base formula, either one. So -2 is the y-intercept. But you just need to be very careful that you're staying on this side of -2, the vertical asymptote. So I didn't say it before to wrap this up. So you get it by taking the x plus 2 equal to 0. Whatever inside there you set equal to 0, that's your vertical asymptote value. Okay, I went kind of quick in this, but if you go through it, it's really not too bad. You just need access to a graphing calculator, and you need to follow the rules on how to find the asymptote. So note that the domain is related to it on logarithms and the range on exponentials. Okay, that's critical. And then finding the intercepts using the work, and then you can actually check on the table to see that they're right. So think about that. So what I'm saying is when you go to your table, you better see them. So you better see -1.5. When you go there, you better see 0. There it is. Okay, and then you better see 0, -2 when you go there. Start it. So if you start at those places, then you should see those values on your table. All right, so this is what you need to know for the next quiz. Again, there's some questions on data, which you could get out of the video, but that's really, really very simple questions on exponential growth or decay data, and then logarithmic growth or decay data.